Namaskar, welcome back. So, this was the last uh, discussion we had on the different type of techniques we are using for mapping the geomorphology or the geomorphic features, or you can say the morphology of the surface before getting into the stratigraphic expressions and the record which is preserved in the near subsurface. So, this was the example of San Andreas fault, which shows the aerial oblique photograph, and it is low sun angle photograph. Now, this landforms, about the landforms, different type of, we will be having a separate topic on this, and we will have detailed discussion on that part. Okay. Let us go ahead and then see that what we also did in India related to this the mapping of the surface morphology. And this was way back almost like more than 20 years. The earthquake of 2001, which was triggered in Kutch region of Gujarat. And we initially we identified couple of faults based on the satellite photo interpretation, but later after, because it was there was an earthquake, so we also planned to do the aerial survey. So, this was the first aerial survey ever done for this type of studies in Kutch, and we collected again this is low sun angle aerial photographs. So, we did very detailed photography of this region, and part of that I have already discussed in the previous lecture also. So, that was also in part of this flight we the sorties we did at that time. That was after 2001 Bhuj earthquake. Now, one can also generate orthomosaic, that is what we call, and plus this the terrain you can see in 3D, the aerial photographs which we have taken. Of course, it is oblique, but then also you can take, because if you take see these three photographs, these three photographs are having almost an overlap of more than 50%, or somewhere it is around 40%, but most of it is more than 50% of overlap, and that is what is required to generate an stereo for vision. Okay, that is 3D perspective view of any terrain. So, this was also done in the during the 2001 after 2001 Bhuj earthquake. So, if you see the close up, so what we did was that we wanted to have an idea that where the extensive deformation has occurred related to 2001 Bhuj earthquake, and whether it was in co-seismic or it was secondary process related to the secondary features. We did not do that part initially, but we wanted to understand that because the epicenter was close to the village known as Buddhamura, and so we flew around that, because what reports what we got was that high seismic shaking, okay, strong seismic shaking was observed in this area. So, according to that, we planned our flight. Nevertheless, we also flew along a couple of areas along the Katrul Hill fault. There are two major faults, not two, but more than two, but in mainland where we see usually the rocky region of Kutch, we have two main faults that are here, Kutch mainland and Katrul Hill fault. So, we flew along that also, and then took the photographs again the same way we did. So, after doing the aerial photography in this Buddhamura area, we also did the field mapping, okay, and that what you see here, that is extensional cracks which are developed here, and then further here what we saw was the like typical upwarped area, which some people believe that this is an co-seismic rupture, but this was nothing to do with the co-seismic rupture. This was related with the landslip, and that is landslip was mainly the lateral spread. Okay. So, this was very typical of the secondary phenomena. Okay, that what we have learned that in the beginning, that the off fault will also have a similar type of lateral spreads and landslip. Okay, because of the strong ground shaking. At the same time, this type of landslips, if they are on the slope, at the toe of that, you will see a sort of a deformation. And this is true for even the landslide. Okay, so if you're having a sort of an elevation change, okay, then whatever the material is coming down here, then at the end you will see some sort of a deformation over here. Okay, so this is common for all areas, even if you are having the gentle area. So here what we saw was that and what we observed in the field was that the slope was very low. Then also this happened. Okay. So extensive cracks and we can say the extensional cracks were been identified, and at the toe, because this was the direction of the slope actually here. So we had an extensional cracks here, and then this portion experienced a deformation. Okay. So close up of that, if you see here again, another one is this one. Okay. So we see a very clear cut overriding of the surface, breaking of the surface and overriding of the surface. Okay. Further, as I mentioned in the previous lecture also, that we were the first to identify the active faults in Kutch region, and this was the aerial photograph which we published, and this was and the trenching site we did successfully. We did the stratigraphic studies also, okay, in this area. Further, this also this if you see the ground photograph of this is exactly, this is over here in this area, this portion what we see is the fault scarp. Okay. Unfortunately, I would say this did not move during 2004 earthquake and has potential to move in near future. Okay. Similar studies using aerial photographs, and this is corona satellite photos, were being used to identify new faults in Himalayan region. Okay. So, and this the ground photograph which you see at the base. Okay, so fault run somewhere over here, and this is the fault expression which we see on the satellite photos. Again, as I told that in 2D you will not be able to look identify the elevation variation of the landforms, and if you look at here, then this area looks very flat. Okay, of course there is some tonal variation, but there are two faults with marks with the black line are passing through that. And as I told that this fault surface expression is this one actually you are having. So this is the surface expression, and we also did trenching here. We will discuss this later on. And the next one, this one is your anaglyph. Okay, that what we use two photographs of the same area, and this is again the satellite data, and procured from National Remote Sensing Center, that is NRSC, Hyderabad, and this is pretty high resolution, 2.5 meter resolution is there. Now, when we generate this anaglyphs, and how we will be able to generate anaglyph, this we will have in separate lab for it. Okay, a demo lab, and then you will learn how to do that. Okay, so this helped us in getting ourselves on the digital platforms. Okay, so initially, as you remember that in the previous lecture we discussed about that we used to use two photographs, the overlapping two photographs of the same area. We use stereoscope. Uh, as I promised, I forgot this time also, but next time I'll try to bring that. Okay. So we used to stereoscope and try to see the uh, area in 3 dimension. Now, the issues or the disadvantage of though using those photographs were that you have to have the print. Okay, that is paper print you need to have. Photographs getting printed takes a lot of time, lot of money, on also you won't be able to enlarge that area of your interest. Okay. So that was a sort of a drawback which we faced in that. Okay. So whichever area you want to see uh, with an enlarged vision, then you will have to again develop that. Okay. So printing again and again uh, lose out the resolution also. And after getting this data, the things were quite easy for us, because this again comes with the on the digital platform, and you can use different softwares to generate uh, anaglyphs. An anaglyph will give you also help you in generating digital surface model of some areas if they are properly rectified. Okay. And also to some extent this data comes geo rectified, so there is no issue on rectification. Again, corona satellite data was not rectified, so you will have to rectify it. But when we did that, because we also wanted again the corona data, if we can generate 3D on digital platform, but it used to come in uh, uh, films. Okay. It's like what we used to use the conventional films for photography. So it used to come in the tape, and that tapes we were cutting and then trying to develop the paper prints. Okay. But in this, you again, like, you can enlarge it, you can view the terrain. So you take one scene and then you uh, like put the tie points, because you have to be very careful that the same area has been tagged with the other image, and that you can do in the software. So tagging the type and putting the tie points as many as you can, that will enhance your image perspective view. It will have a good overlap sort of, and that you can, so you will not have any sort of a distortion. So that part you will learn. So this was one of the advantage. And if you use, so finally looking this image in 3 dimension, you need to have the glasses, okay, of different filters. Okay. So that filter glasses, if you use that, then you will be able to see the terrain in 3 dimension. So this is 2D image. The previous one was your uh, anaglyph. Okay. So 2D image, again, as I told, that you won't be able to identify the features. So this part, if you see, is from this region. This is the part in the next image. Okay. And we did detailed mapping using anaglyphs, and this is the anaglyph of that area, which allowed us not only to identify the faults, but also the landforms associated with that. Okay. So that what we call terrace risers and all that. So what are terraces? What are the terrace risers? We will be learning slowly in coming lectures. Okay. But this is just a part of the technique what we are using, the aerial photographs or satellite data and all that. Okay. So if finally what we need is the detailed topography, not topography, but the topography of the fault, as well as the geomorphic features. Okay. So this map, if you see, as I was discussing in the previous lecture, that we need to identify and generate a chronology or the stratigraphy of the landforms also. So older landforms, then younger landforms, and all that. Okay. So that if those landforms, older as well as younger, are displaced, then you will be easily able to conclude or infer that this fault has remained active since long. Okay. So that is one advantage. Plus, the advantage is that you will be able to identify or fix the trenching site uh, on the younger displaced landform, or across the younger displaced landform. So that is then advantage. So here this T1, T2, T3 are the terraces. Okay. So if I just quickly explain you that what are the terraces, then suppose you have a river channel. This is a cross section of the channel. Okay. So this is the channel bed, and since we have the depositional as well as erosional terraces, I'll just put the terraces how it looks like. Okay, if you see in the cross section, so you have the terraces which will be forming like this. Okay, so if you are having paired terraces, then you will see like this. If you are having unpaired terraces, then you will see something look like this. Okay, so these are the terraces, and terrace chronology usually is seen that this is the younger one, the close to the channel. Okay, so river bed close to the river bed will be younger. Okay, and as you move like in the upper sections, those are the older ones. Okay, so this part is exactly opposite of the stratigraphy. Okay, so this is here T0 here, this is T1, and this will be T1 here. So these are unpaired terraces, and this is paired terrace. Okay, so you have like this will be the younger. Okay, the T0 will be younger, and T2 here. Okay, in the first case, that is your A. Okay, so in case of the A, you have T0 which is older. Whereas in the stratigraphy, what we see is that you have the section and you have sedimentary units. Okay, so you have at the base, so this is your base. Okay, and this is your top here. So suppose you have A, B, C, D, and so this will be older and this will be younger. So this is totally opposite here what we see. Okay, so in case of the terraces, the classification what we do in terms of the elevation and all that, as you move away from the channel and you go on the elevation, you gain the elevation, then you see older terraces, and that's what we see here also. Okay, so we have these are the all channel. This is the boundary of the channel, paleo channel again. Okay, and we have this T1, T2, T3, and T4, and they have been dissected by this faults which have been marked by red arrows. Okay, so these have been dissected by this faults here. So this is a fault topography here. So one goes here. Okay, another goes here. Okay. So tectonic geomorphic map preparation is very much important, and as I told that you can use multiple ways draping your image on DEM or digital elevation model prepared from the cartoset, and the picture which you are seeing right now is a 3D perspective view of Kangra Valley, which we used the cartoset data. Cartoset 1 data, we generated first the anaglyph, and then we also used, so after anaglyph we used the draping of, so on this too we drape the any one of the image, either so it was after or forward image. Okay, and that gave us the 3D perspective view of the terrain. Okay, and the arrow which has been marked here, you can see this as the fault which runs through this ore. Now this was been done in one of the software which is available on, it is paid software, and that is what we call NV. So you have different versions of this, you can buy and you can use it. Okay, so this was one of the attempt which we did with the cartoset data. DEM was also generated from cartoset, as well as the draping of the image or the photo which we did was from the cartoset. And as we were discussing in the previous lecture, we used SRTM data and we draped Landsat data on that. Okay. And this is what the same which I was just mentioning about, that this we have done for Chandigarh area, but the data which we used here was SRTM, and we had the draping of the Landsat image. And finally, as we have been discussing, that the main goal is to generate the detailed landform maps as well as the fault map, okay, on this. As it has been shown here, that you have on the left you have the corona satellite photos, and on the right you have a detailed map which includes the landforms and faults which are cutting this landforms. Okay. Now, as we have if we move further and we see the stratigraphy, about the stratigraphic expression. Okay. So, sedimentary and geomorphic mapping, if we are talking about, then mapping of quaternary deposits, which can be differentiated on basis of a depositional landform or sedimentary structures, internal geometry, size and shape. So, how we are going to what mapping we are going to do in terms of, because we are dealing with the quaternary deposits. Okay. And as I have been mentioning right from the beginning, that we are mostly interested in active tectonics and paleoseismic investigation. We are mostly interested in having the history of last 10,000 years. So, this the mapping part will help you in differentiating the depositional environments. Okay. Very simple. If you are having, for example, clay deposits, okay, like if we take a section, this is the base. Okay, you have gravels. Okay, you have gravel, and on the top, suppose you come across a clay deposit, and then you are having sandy, then again you are having gravel deposits here. Of course, you will talk about the gradation and all that over here, but this is indicating sort of an either channel deposit. So, this shows that the channel used to flow in this area, but this shows a sort of an calm environment. So, either it was a cutoff channel or you had an oxbow lake in the alluvial plain areas or something like that. So, there is some sort of an ponding condition, but the low energy events, okay, or deposition environment. Then this was, you can say, overbank. Then again you are having getting into the channel. So, change in environment you will be able to identify if you are carefully mapping this. Okay. At the same time, we also try to look at the sedimentary structures, internal structures, what we see, internal geometry, and the size of the detritus. Okay. But what is the size of the gravels? Okay. Whether the gravel can be right from the granules to boulder. Okay. So, what is the size of that? Because that also will help us in understanding whether there was any change in the environment, whether it was related to the climate or it was related to the tectonics also, that you need to identify. Okay. By this mapping, one can also differentiate whether it was fluvial deposit or glacial or aeolian or lacustrine deposit, or it was just a mass wasting, that is a landslide. Okay. So, slope. So, that also one can differentiate between this. Okay. And this is the reason why we emphasize on the sedimentary mapping. Okay. Further mapping of individual landform helps to distinguish between the geomorphic environment also. Okay. What is the superficial? Because the 2 points here, the top one, we are talking about the deposition environment. Okay. But the geomorphic environment also helps us in differentiating the landforms. Okay. Now, within alluvial environment, we have alluvial fans, stream terraces, floodplains, etc., and mapping of primary paleoseismic features. Okay, that is your fault scarp related to active deformation. So we see warped surfaces, offset channels, dislocated terraces, or uplifted terraces, raised beaches if you are along the coastal line and all that. Okay. So differentiating from the primary depositional and tectonic feature are important. Hence, we have to be very careful about the mapping part in terms of the surfacial morphology and in the stratigraphy. So, with this, I'll stop here and we'll continue in the next lecture with more details on this part. Thank you so much.